Wanted. Parent functions. 8 functions are on the loose, and we need your help to identify them. First function, the constant function. Alias, y equals c. We see a member of the family right here, y equals to 2. Domain, all real numbers. Anything can be plugged in. Range, well, it's whatever the constant is. It is always constant, of course, never increasing or decreasing. Level as the plane in Kansas. No maxes or minimums. And as long as y isn't 0, it doesn't intersect the x-axis. Second function, linear function. Y equals x. Domain, all real numbers. Range, all real numbers. It does not leave anybody out. Always increasing, but this is subject to change. It could transform in some way that improperly reflects itself. No maxes or minimums. Goes right through that origin. Wanted, quadratic function. Alias, y equals x squared. Domain, all real numbers. It doesn't choose to eliminate any x values. Range, all values bigger than or equal to 0. Never negative, but don't let that deceive you. This function decreases from negative infinity to 0, increases from 0 to infinity. Some days it's decreasing, some days it increases. Minimum at x is equal to 0, which happens to be its x-intercept and y-intercept. That too is subject to change. Wanted, cubic function. Alias, y equals x cubed. Domain, all real numbers. Range, all real numbers. It stretches its hands out everywhere. Increases everywhere. Never has any relative maximum or never has a relative minimum. Goes right through that origin, just like so many of these functions. Beware. Wanted, square root function. Written as y equals square root of x. Domain, all x values bigger than or equal to 0, subject to change depending on any shifts or any reflections. Range, x bigger than or equal to 0, also subject to change. Increasing from 0 to infinity, never decreasing unless something happened to it. No relative maximum or minimum, also goes through the origin. Well, sort of goes through the origin, stops at the origin. Wanted, absolute value function. That's the function with the bars around it. Looks like a V. Domain, all real numbers. Range, y bigger than or equal to 0. Just like the quadratic, looks so similar to it, but it is composed of 2 linear functions defined on their own domains. Decreases from negative infinity to 0, increases from 0 to infinity, also subject to change. You never know what this function will do. Minimum at x is equal to 0, also passes through the origin. Semicircles, they're kind of unusual, so be on the lookout. For example, y is equal to square root of 9 minus x squared. This is a semicircle with a radius of 3. Where does that 3 come from? Square root of 9. Domain, negative 3 to 3, including both ends. Range 0 to 3, also subject to change depending on how big the semicircle is. Increasing from -3 to 0, decreasing from 0 to 3. You never know, this could be reflected into the third and the fourth quadrants instead, and then everything changes. Maximum x equal to 0. Wanted reciprocal function, alias y equals 1 over x. They call it the rational. I don't know how rational it really is, though. It's going all over the place. It even has these weird things not seen by any of our other wanted functions called asymptotes. A vertical asymptote at x is equal to 0. A horizontal asymptote at y is equal to 0. Domain is everything except for 0. What happens? It avoids that origin like the plague. Range also avoids the origin, avoids y is equal to 0 as a possible value. Decreases everywhere except for at 0. 0 is not in its domain. No relative maximum or minimum. You may be deceived. It may look like this is a relative minimum, but in fact, it truly isn't, because this function just keeps decreasing and decreasing. You think you've got it. You think that it reaches y is equal to 0. This horizontal line, y is equal to 0, but it never does. What a shame. Finally, cubic root functioner. Alias, y equals cube root of x. Strange notation. Looks kind of like the square root, but has that 3 there to indicate we're dealing with a cube root. This is something that looks very similar to a very, very tired cubic function. It's laying down sideways. Domain all real numbers, range all real numbers, just like the regular cubic function. But don't be deceived. This function does also increase on all real numbers. No relative maximum or minimum. But you might think that this, just like the reciprocal function, has a horizontal asymptote, but it really doesn't. It keeps going and going. When you think that you've got it, it just keeps at it and never stops. These are our wanted functions. Be on the lookout.